Hey everyone, I've wanted to make this video for a long time, which is a comprehensive tutorial on how to build a data platform from scratch using cutting-edge tools like Databricks and Apache Airflow. What I'm hoping to achieve is to give you guys a rough understanding of how a large company might build their data infrastructure to support their AI and ML workflows. This year has been a pretty crazy year of AI, where every day new tools from Anthropic and OpenAI are currently being released. And they're obviously very nice and shiny. However, data platforms are really the backbone of AI. Whenever you make a call to ChatGPT or any kind of large language model, you're really just solving the problem of data retrieval, context engineering, storage, using best practices as a software engineer. Today, we'll be building an end-to-end data platform from scratch using Databricks and Airflow 3.0. Airflow just dropped their major 3.0 version last April, and it has a lot of new exciting features such as DAG versioning, asset-based orchestration, and it even has a new web server written using React and Fast API. Whereas Databricks, you can think of it as a unified tool that originally started from the Apache Spark project, but has grown into a large player within the AI space. Key things I wanted to cover in this video is Databricks fundamentals. It's very important to nail the fundamentals and understand the business context of why we build data pipelines. So I'll walk you through Databricks workflows, clusters, notebooks. The second thing is that we'll run Airflow 3.0 on a local Kubernetes cluster. For those of you who don't know Kubernetes, it's a container orchestration tool used by every single large company I've worked at. Now, there are a lot of easier ways to deploy Airflow. You can run it on managed services, you can run it on vendors, but from the lens of a large company, when you need to scale Airflow to thousands of users, Kubernetes is usually the obvious choice for a lot of big companies. If you're a complete beginner, don't worry. I'll do my best to try and talk through every step of the way. The only prerequisites I have for you is that you know Python and SQL, you are familiar with containers and AWS, and finally, you have a strong interest in big data and distributed systems. There's a lot of things I want to cover in this video, and I don't have that much time, so let's dive right in. I want to quickly spend some time covering high-level architecture of what we'll be building today, and I'll split this into broadly three parts. The first part will be building data pipelines using Databricks. I want to nail down the business side of things, and essentially our jobs as data practitioners is to generate business value for stakeholders using data. We'll achieve this by using Databricks primitives such as notebooks, clusters, workflows, and I want to show you how I create Spark pipelines, how I trigger them, how I think about design patterns. For Databricks, we use this data lakehouse architecture, and for those of you who don't know what that is, you can check out this paper. So this paper was written in 2021, I believe, by the creators of Spark and Databricks. It's quite an old paper, but I still think it does a great job giving people an intro of what a data lakehouse is. In the past, people would operate under this data lake architecture, or essentially a lot of companies would have data warehouse and ETL pipelines operate under a data lake like Amazon S3 with Parquet files. And you would have a bunch of workloads, whether it's analytics, data science, or more hardcore machine learning. It turns out that there are a lot of issues with a traditional data lake, because what if you have two Spark jobs trying to write or read files from the same location? What if you want to version your data? What if you accidentally drop a table? So there are a lot of problems with a traditional data lake. A lake house is a next generation evolution of a data lake, where instead of using Parquet files, we use open file formats such as Delta Lake, Apache Iceberg, Apache Hudi. And the advantage of this gives us is that, number one, it gives us this ACID property. So in database, there's this concept of like whether you have atomicity, you have isolation, you have durability. And the second thing is that it gives us a layer here that gives us metadata management, caching, indexing, so forth. So with Databricks, we have something called Unity Catalog. And Unity Catalog is essentially Databricks' flavor of a data lakehouse that has a lot of nice features such as fine-grained access controls. It gives you lineage, helps you with delta sharing, a lot of APIs. Also has more features such as performance optimization using liquid clustering, predictive optimization, stuff like that. So that's what a data lakehouse is in a nutshell. So let's go back to the slides here. And I also want to talk very briefly about how to serve data to your users. Now, whenever you write data pipeline, you have to think about who your users are. Are they technical enough to just go into your database and run a bunch of queries? Or are they non-technical, C-level people who just want a dashboard or some kind of service that you can get data and get results? So Databricks has a new feature called Genie that allows you to chat with your data. So we'll look into that super briefly. We'll be saving all results on notebooks into GitHub as our source control management tool. For the second part, for Airflow, Airflow is our orchestration layer, and we'll be running it using a local Kubernetes cluster. I want to approach this part from the perspective of a software engineer. Each pod in Airflow is going to represent one task. And this gives us the benefit of having great isolation for your Docker images, and it also allows you to scale to tens of thousands of users. We'll look at how to create a local Kubernetes cluster on Kine. For those of you who don't know, Kine is this tool. Yeah, so Kine is a tool for running local Kubernetes cluster using Docker container nodes. And it's primarily designed for testing and local development. And we will be using the official Airflow Helm charts. So Helm chart is, if you go into artifacthub.io, go to this website, a Helm chart is essentially some kind of recipe or template that allows you to bootstrap an Airflow deployment. And you can see here the latest Helm chart version is 1.16.0. I believe 1.17.0 came out a few weeks ago. So we'll be using the newer version instead. And there's several ways you could also deploy Airflow. You could deploy them on Astronomer. You can deploy them using Docker Compose. You can deploy it locally. We'll be using Kubernetes for this video because it's often the most production ready for large companies. For startups, I don't think running Airflow on Kubernetes is necessary. It gives you a lot of headache. It has a lot of overhead. You need to hire SREs to maintain your clusters. But I think this is a great project for learning purposes, and it gives you an idea of how enterprises do it. For the last part, we'll talk about deployment, and we'll look at some really basic CI/CD using GitHub Actions. How can you push a custom Docker image into AWS's container registry, which is ECR. So ECR stands for Elastic Container Registry. And we'll pull that image into our Kubernetes cluster. So let's go ahead and set up your Databricks account. My goal is to help you get set up and give you a tour before we dive into the coding section. So go to your browser, and what you need to do is sign up for a Databricks account. If you use your work email, you should be able to get a $400 free trial, but I don't think the free trial has all the features you need if you want to follow this video exactly. So if you want, you can put your credit card down, but make sure to delete everything after you're done. So just click sign up. And I've already signed up, so I'm just going to go to my Databricks console here. The other thing is you need an AWS account set up, so make sure you have that. So this is what the Databricks console looks like. I'll give you a high-level tour of the tabs on the left-hand side. So Workspace is basically where you store your Databricks notebooks, your SQL files, your Spark queries, your dashboards. It's where you would store things for your IDE or development experience. And typically you would have a lot of users in a workspace writing files, sharing notebooks with each other. And going to catalog is another important thing. So a catalog is Databricks' version of their database, your schemas, your tables. And for my account, my default catalog is called Data Platform Tutorial, and it has a schema called default. And currently this schema has no data. You can also find some information schema about your tables here, your catalogs, your columns. There's also data about your system, so how much money you're getting billed. And you also have your old Hive Metastore catalog here, but this one's deprecated basically. So this is what catalogs look like. Another thing worth noting about Unity Catalog is this. yeah, so this is what I wanted to show you. So what is Unity Catalog? You can think of a catalog as having 3 layers. The first is your catalog, the second is your schema, and under your schema you can store things such as a table, a view, and a volume. Your volume could be an internal volume managed by Databricks, or it could be external volume that has an underlying S3 bucket location. So, yeah, so that's basically what you need to know about Unity Catalog. Let's go back to the console here and click on Jobs and Pipelines. So Jobs and Pipelines is where you would create Databricks workflows, and Databricks workflows are quite similar to Airflow DAGs, but not quite the same. I would put them closer to some kind of data transformation tool like dbt rather than Airflow. So you can stitch together different notebooks, you can stitch together Python script, SQL, you can even use dbt here. You can put a bunch of Databricks code together and run it as a DAG or a workflow. So that's what this job here does. ETL pipeline. ETL pipeline is a pretty new feature in Databricks. It's basically a way of creating declarative transformation pipelines, and maybe this is for another video. For compute, so compute is quite important. This is where you can create a custom compute, and I'll do this in a second. If you have the free trial version, you might not have access to this compute page. It might redirect you to this SQL warehouses page where you can only create a serverless starter warehouse. If you want to have your own compute, you have to put your credit card down, and what you have to do is you might have to go to your Databricks workspaces and then recreate a workspace and configure it. Yeah, so when you create a workspace in your Databricks management console, you might have to click this option for storage and compute, not the default serverless one, and then you would have to deploy your workspace using AWS here and follow instructions. So just a heads up in case you don't see the compute section in your console. If you want to follow along without putting a credit card, feel free to do so. It's optional. Okay, SQL Editor. SQL Editor is a place to run SQL queries directly on your tables. And this is especially useful for people who are not so technical. So think about users like data analysts, data scientists. They would typically come here and write ad hoc queries over your databases. A company that Databricks acquired, actually, I think it was this company called Redash. Yeah. So dashboard, you can create dashboards here. There's Genie. Databricks Genie is a new feature that allows you to chat with your data. There's also this AI and ML tab where there are a bunch of new features for AI agents, all that cool stuff. TLDR, the important ones are workspace, catalog, jobs and pipelines, and compute. The dataset that we will be using for this project is this Stack Exchange dataset. So go to archive.org/download/Stack Exchange. And this is basically an archive of all Stack Exchange posts in the past, up to 2024. And there's a schema for this. If you search up Stack Exchange database schema documentation, you should be able to find this page that tells you about, oh, this dataset is going to give you this post table that includes things such as the post ID, whether a post is a question, whether it's an answer, whether it's a tag wiki, some metadata about when the post was created, what's the parent ID of the post, the score of the post. Scroll down. There's also data about users. So their user reputation, when was the user created, what's their display name, their upvotes and downvotes. And there's a bunch of other tables for comments, badges, so forth. So this is the dataset we'll be using. I'm just going to click this AI.stackExchange dataset. So I'm going to download this one. So click download. I already have this file downloaded, so I'll just go here. Whoops. Yeah. We'll only be using these two files, post and users. And let's head over to catalog here. I'm going to click on my default catalog, which is data platform tutorial. Click on my default schema, click here, and I'm going to create a volume. And make sure when you create a volume, click manage volume. Let's call it my volume. Hit create. Once I'm here, click on files, upload to this volume. So I'm just going to quickly drag posts and users to my volume. Upload. Okay, so I have posts and users uploaded into my volume. In terms of where this underlying data is stored, it's good to have a rough idea of what Databricks file system is. So I'm just going to show you this really briefly. Really quick intro to what Databricks file system is. Okay, this diagram is kind of confusing, but basically your internal and external volumes are going to fall into this bucket here. And for your mounts are deprecated, I believe, or they're not advised by Databricks to use. So you can just ignore this for now. And the rest of your code base for your files, your notebooks is going to be stored in this file path system here. So in Databricks, there are really just two main prefixes. One for DBFS, which is your actual data, and your file prefix is for notebooks and SQL queries and dashboards for different users in your workspace. So yeah, so the important things to know is DBFS, volumes, and then file, workspace, and users. Yeah, just high level of what DBFS is. Let's go back here. Okay, so once you have your posts and users in your volume, so I'm going to go to workspace and let's create a notebook. So let's create a notebook. Let's call this bronze posts. And let's call this bronze posts. Before that, let's go to posts and take a look at what the data looks like. So I'm just going to click on post. So this is what post data looks like. You can see it's an XML object with a post tag here, and each row is represented by this row tag. So we need to parse these properly using Spark. Just a heads up, this is what the data looks like. But let's go back to our notebook here. df equals spark.read.format XML. Let me wrap this in bracket. Dot option root tag posts dot option row tag row. We'll do option. Let's infer the schema for now. Upload. Now we need to put the volume path. So let's go to catalog. Let's go to your volume. Go to post. Click here. Copy path. Paste your volume path here. Okay. If you want to run this, you need to attach a cluster into your notebook. So over here, let's go to compute and click on create compute. For my compute, I'm going to disable photon acceleration. This is expensive unless you really need photon acceleration. You can pick the latest Databricks runtime version. I'll use 16.4. For worker types, there are different instances you can pick in AWS. There's storage optimized, there is memory optimized. For me, I'm just going to pick the cheapest one. So I'll pick general purpose M4.large. So make sure to pick M4, not M5D. The D stands for Delta Cache Accelerated. So pick M4.large. I'll disable auto scaling. I'll set it to 3 workers. Create compute. So I've already created my compute. Here it might take about 15 to 20 minutes to spin up a cluster. So I'm just going to pause the video right here. Listing. Okay, so now that I have my cluster all set up, it's ready to go right now. Let me just close my tabs here to make things more organized. So after I spun up my cluster, you can go to AWS and you can see your EC2 workers running. So these are your Spark workers. There's one EC2 instance for your driver node and 3 instances for your worker nodes. Okay, my cluster is set up. So let's just focus on the coding part now. Yep, so let me attach the cluster to my notebook and let's run this cell. So we're reading from this post file and we're inferring the schema. Let's just double check let's do a sanity check on the data. So let's display df.limit.10. Let's just see the first 10 rows. Okay, so here are the first 10 rows. You can see these are what the columns look like. Yeah, you might be very tempted to infer the schema every time you're reading files, but in practice, schemas change all the time. So what I normally do is I would do df.print schema here. And once I have the schema, I would write down the actual schema structure itself. So let's go ahead and do that. Yeah, so I'm just going to copy paste some code here. Yeah, so this is the code I'm going to copy paste. Basically, I took this string here. What I normally do is just copy paste this. Actually, let me just show you how I do it. So I normally just do this trick where I press Command I, and this lets you use Databricks version of ChatGPT. And I would do create a Spark schema struct type for the following fields, and then paste it here. Okay, so this is the schema that you want, accept, and then run this. Then what we're going to do is let's copy paste this code. Let's go to the bottom here. So instead of inferring schema, let's do dot schema schema. Run here. So this should be slightly faster. Okay, let's comment this out. Yeah, the other thing I don't like about this table is that there's a bunch of underscore prefixes here. So let's go ahead and remove that really quickly. I'll do new column names equals call for call in df dot columns. And let's do df equals df to df. And we'll just put in the new column names. So let's do new column names here. So this should replace the data frame names. Yeah, so this looks good. We can see all the columns look nice now. So once we have this, let's just write it to a table. So let's do df.write.mode overwrite dot save as table. And let's call it raw post. You can even do dot option overwrite schema equals true in case you want to rewrite tables if you made a mistake. So let's go ahead and save that. Okay, so let's go ahead and save this data frame as a post. And if you go to catalog, you should be able to see the table here. Yeah, so you should be able to see raw posts here. If we go to Catalog Explorer, click on sample data. Yeah, you should be able to see some sample data here in raw post. Let's go ahead and do the same thing for users. So go back to your workspace. Let's create another notebook. And let's call this one bronze users. So with bronze users, let's do the exact same thing. Feel free to pause the video and try to do this yourself. Equals spark.read.format XML dot option root tag post users dot option row tag row dot option infer schema true dot load. Let's go ahead and copy paste the volume path for users. Copy path, and let's paste it here. Let's attach the cluster. Let's hit read. And while this is running, let's do df print schema. So once you read the users table, we can print schema. Let's do the same thing. Like create a Spark schema struct type using the following fields. Okay, accept. I'm going to copy paste this again, comment this out, paste it here. Instead of dot option, let's do schema. Let's read this. Oh, whoops. Let's do the same thing. I want to remove the underscore. So new column dot names equals call one for call in df dot columns. Let's do df equals df dot to df new column names. A quick sanity check that our data frame looks good. Let's print the first 10 rows. Okay, so everything looks good. About me looks good. Account ID, creation date, display name. And let's write our data frame. So df.write.mode overwrite.option.overwrite schema set to true. We'll dot save as table. And we'll save it as raw underscore users. Once you save it as raw underscore users, go to catalog. You can see there's raw users, raw post. So now that we have tables for raw posts and raw users, we've ingested it to some kind of raw location. What I would do is normally create data quality checks immediately after I ingest the raw data. And the reason is that most data quality issues typically happen at the start or as close to the data set as possible. And you don't want your users downstream to be able to find these data issues. You want to catch them super early on. So this idea of shifting left in your data quality checks. So let's go ahead and create a data quality check for post. Now there are a bunch of different frameworks you can use to create data quality checks. I'm just going to use this one called Databricks DQX. Yeah, so this is a framework that recently came out from Databricks Labs. So this is the one I'm going to use. It's DQX by Databricks Labs. So let's go back to my workspace and let's create a new notebook. Let's call it bronze post DQX. To install Databricks DQX, install Databricks Labs DQX. So while this is installing, you can run pip install here. The other option is you can go to compute, click on your cluster, click on libraries, and you can install libraries here using PyPy. But if you install library, you might have to restart your cluster and take a long time. I'm just gonna do pip install. Okay, so while this is installing, now you need to restart your kernel. So let's do db-utils.library.restart Python. Okay, now we've restarted our kernel. Let's do raw post underscore df equals spark.read.table, and let's get the raw table that we just created. So let's do raw post. This is the documentation for Databricks DQX. Yeah, so I'm just going to copy paste this example here. So with DQX, you need to essentially create rules, and each rule you can specify how critical the rule is. And there are a bunch of pre-built checks that are already available for you. So for this example, check if the function is not null or not empty. So let's go here. I'm just going to import a bunch of libraries. I'm just going to import a bunch of libraries from this website here. And let's do DQ engine equals DQ engine workspace client. And let's create some checks. Let's copy paste this. Yeah. So the DQ for each call rule. So for each column, and for each column ID and creation date, let's specify an error. And for my function, let's do check funcs is not null. So the first rule is that for each column ID and creation date, I just want to check if each column is not null. And this is a critical check. Very easy. Get rules. And let's add a couple more rules. Let's add DQ row rule. Let's call this rule creation date not in future. Let's create this. And over here, I want to check if my creation date is not in the future. So basically, any rows with creation dates past 2025 in July or August, I want to flag an error. So let's do creation date. Let's write one more rule, DQ row rule. Name equals post type ID, allowed values. And over here, let's do criticality equals warn. Now the cool thing about DQX is that it has this ability to quarantine data. And whenever you use a warning check here, so is in list, whatever rows that isn't in the specified range, it's going to quarantine that data. And as a user, you can think about how you want to handle these quarantine data. So I'll give you an example. So let's say for post type ID, I want to check if I can only allow these values. Let's say I want to allow 1, 2, 3, 4. Let's say I only want to allow these 4 values here. So the way you apply these checks is you can do DQ engine .run apply checks and split. And I'll pass in my data frame, raw post data frame, and pass in my checks. And over here, I will get back a valid data frame and a quarantine data frame. So this is pretty good. You can get your valid rows in your quarantine data frame, and you can figure out how you want to handle these quarantine values in DQX. So let's run this. Okay, there's an issue here. It says oh, it's a typo. Okay, typo. Let me rerun this again. And let me display quarantine_df.limit.10. Okay, so this is pretty cool. My quarantine data frame is going to return me post with post type that is not in the range 1, 2, 3, 4. Okay, once I have my data quality check, I'm ready to move on from the raw step to the staging step. So let's go back to workspace here and let's create a new notebook. For this one, let's call it silver post. Silver post is where we're going to stage our data, enhance our data, do some processing. So this is where the bulk of our logic is going to be. So raw post df equals spark.table. Let's just read the table. Raw post. Okay, let me just print the data here so we can just reference it as we're writing code. Okay. Okay, now let's write our transformations. Import pyspark.sql.functions as f. Then from pyspark.sql.types, let's import struct type, struct field, mat type, integer type, and string type. From pyspark.sql import dataframe. So instead of writing transformations line by line, I'm going to create a bunch of declarative functions to do my transformations. So let's do define split tag into array. So this function is going to accept a data frame, and it's going to return another data frame. Okay. Just write the function signatures first. So let's do rename columns df data frame. So this is how I'm going to apply my transformations. I would write these skeleton functions for how I want to define my transformations, and I would pass them like this. So raw post df dot transform. Copy paste this, paste dot transform. Rename columns and dot transform map post type. This is a much cleaner way to define transformations. So instead of writing it line by line, the main benefit of being able to write these declarative transformations is, what if you're revisiting this code 5 years in the future? How can you make it easier for someone in the future to make changes for your code base? So let's go ahead and implement this split tag into array. Let's just return df.with column. So I'm just going to create a new column called tags array, and I'm going to filter. So if I go to tags here, you can see each tag is split by this special character here. I want to get an array of tags here. So that's what split tag into array function is doing. So let's do f.filter, f.split, then let's do f.call. Let's get the tags, and so this is the special character that I want to catch here. And I'll pass in a lambda function, x is not equals this. And let's do drop tags. This function is basically, I want to take this tags and create an array of tags by splitting the character here. Okay, let's see if this works. Oops. Now let's rename the columns. So let's rename some columns df.with column rename. I'll rename the ID, and let's call it post ID. For map post types, let me go back to the Stack Overflow Stack Exchange schema. For map post types, so map post types is basically this part here. I want to map these post IDs to the actual string of the post type. So I'm just going to copy paste this, go to silver post, and let's use ChatGPT, Command I, create a map df that maps these numbers to the following strings. Let's generate. Okay, this looks good. So I created a map data frame that maps these numbers to the post type. And once I have this, I can just do something like df equals df.join. Oh, I can just return it actually. So once I have this map df, let's go ahead and join it with the main data frame. So df.join into map df. Let's do f.broadcast map df. And we'll do df post type id equals map df post type id. We'll join it. We'll do a left join. Then we'll drop the map df post type id. Okay, let's run this. And let's just check the first few rows. So let's display okay, so it looks good. We can see that we generated our tags array, which is an array of string. And we've also generated the post type. So we've mapped the post type ID to the post type string here. So this is a question, this is a question, this is an answer. Okay, let me rename this to stage post df. And let's rename this. Let me just delete this and rerun this again. Whoa, so this transformation happened in 1 second. Now, did Spark actually finish this transformation in 1 second, or like why is it happening so fast? So in Spark, there's this idea of having lazy evaluation and actions. This is pretty important to know. All transformations in Spark are lazy in that they do not compute the results right away. Instead, they just remember the transformations applied to some base data set, and Spark will automatically tune these transformations by analyzing the query plan and optimizing it to some kind of physical plan. So that's what Spark is doing. So there are certain operations that are actions that will trigger the actual transformation. So if I just define the transformation like this, it's not actually doing anything unless I do stage post df, unless I display it. So if I display it, limit 3, limit 5, then Spark is actually applying the transformation. So this is a very important thing to know. You can actually view the transformation plan. So if I go to, if I do staging post _df.explain, this will tell you what Spark or Databricks is doing underneath the hood. So over here, it's doing a file scan of the Parquet file. So it's just reading all the columns from this raw post dataset. It's applying some kind of filter, and it's applying a broadcast hash join. So yeah, anyways, this is pretty cool. Spark will tell you how the query plan is optimized before it's actually transformed to a physical plan. Okay, so once I have this, it's time to write our intermediate files to a table. So instead of doing a normal full refresh write, I'm gonna do a incremental upsert. So incremental upsert, let's do it using delta table. So let's do from delta.tables, import delta table. Let's do import pyspark.sql.functions sf. Now, let's create a function called incremental upsert. And in this function, we're going to pass in a destination table, which is a string. We are going to accept a data frame. We will accept a unique key. Every time you're doing incremental loading, you would need a unique key. We need some kind of cursor or a way to compare data to when is new data, when is old data. And we're going to create a field called updated at. And this is also a type string. And the last one is we'll have a flag parameter called full refresh. And this will be set to false. Okay, so once I have this, let me just close this. So over here, if the table doesn't exist yet, I want to do a full refresh. So that's the logic I want. So if not spark.catalog table exists, so that if the table for destination table doesn't exist, or if you just want to specify a full refresh, let's do df.write.format delta overwrite dot option overwrite schema. Let's set this to true, and we'll do dot save as table. Okay. So this is just saying that if the table in my Spark catalog hasn't existed yet, or I just want to specify a full refresh, create the table from scratch. Yeah. Else, let's do incremental upsert. So in order to do incremental upsert, the first thing you need to do is we're going to assume a table already exists, and we need to get the last updated max value when the table was inserted. So let's create a variable called last max equals spark.table dest table dot aggregation f.max. Let's get the maximum value of updated at dot alias max timestamp. So we'll just call this max timestamp, and we'll do collect. So collect is a action in Spark. We'll get the first value of collect, and we'll get max ps. So this will get you the last max of the current table. Then we'll do incremental df. Let's call this incremental df equals df.filter f.call updated at greater than last max. So this line is very important. Basically, we only want to filter for rows in your incremental data frame that is above this last maximum. That means, let's say we've already loaded data for the month of July. And then in the month of August, I only want to filter for data past July. So this line here is very important. So once we have this, if the incremental data frame is not empty, so rdd. So if the incremental data frame is not empty, let's do an upsert. So we'll create a delta table equals delta table for name spark dest table. So once you created the delta table for name, let's do the upsert now. So delta table.alias t. Whoops. Let's do dot merge. And merge is going to accept a source and is going to accept a condition. For source, we need to specify the incremental df. Let's alias this as source. And for condition, let's do s dot unique key equals t dot unique key. When matched, update all. When not matched, insert all. Dot execute. Let's take a look at what this code is doing. So when your incremental data frame is not empty, we will merge the current data frame from your destination table into your incremental data frame. And you're merging it using the unique keys of both data frames. When it's matched, you want to do update all. And when it's not matched, you will insert all these values. So for new tables, for new rows, they're going to be inserted. For rows that you want to update, it's just going to update all the values using this as a unique key. Okay, so this is basically it. This is basically your incremental upsert. So let's go ahead and run this function. Best table. Let's call it default.staging post. So this is my target. And let's do incremental upsert. Let's do best table staging post df. Let's do post ID as a unique key, and let's do creation date as the updated at key. Now, creation date is not really a proper updated at key. Ideally, you would want to take like a combination of when the post was created and updated, merge it together, and then use that as a key. But just for simplicity, let's use creation date. So let's run this. Okay, so this Spark job ran in 11 seconds. So let's talk about optimizing our Spark writes a little bit. So let's do optimize Spark writes. Now, if I do spark.table.destinationTable.rdd, get number of partitions. Yeah, if I do Spark table destination RDD get number of partitions, right now Spark is only writing the table into one partition, and the reason why it's using one partition is the file is very small, so it can fit into one partition. The ideal size for each Spark partition is around 128 megabytes, so Spark partition sizes. Yeah, so the default sizes are, like the ideal would be 128 megabytes. And there's a lot of material out there in terms of how to optimize Spark jobs, how to reduce shuffling. But the gist of it is that the rule of thumb is you want to have number of partitions as a multiple of the number of executors you have in your cluster. So what does that mean? If I click on my Spark jobs here and click on executors, I can see that, oh, okay, there are 4 executors. Yeah, there are 4 executors being used. So I want to pick a multiple of the number of executors. So let's say, so I could do something like incremental upsert destination table staging post df dot repartition. I'll just pick 4 because I have 4 executors there. And then I'll do post ID creation date. Let's set full refresh equals true. Okay, so let's rerun this. It's going to be a bit faster, but I don't think it'll make much of a difference in a small data set. The other thing you could do is also you can set some configurations in Spark, such as Spark SQL shuffle partitions. And there's also Spark default parallelism, which is the default number of partitions set by Spark. Yeah, so you can also do something like this, Spark conf.set, to tune the number of shuffle partitions you have. And once you do that, because we've upserted data, if we print the number of partitions again, you can see, okay, we have 4 partitions. So let's go back to workspace, and I'm going to create 2 more notebooks. Let's create some marts tables. So let's do go post users. I'm going to quickly do this one. So stage post df equals spark.table default stage post. And we'll do raw users df equals spark.table default.raw users. So I'm just reading both of these tables. Yeah, so while this is reading, I'm going to create one big table. So one big table is this concept in data modeling where you basically combine all your fact and dimension tables so that you can serve it to your users directly and you can put it into dashboards. So let's do from PySpark.sql import data frame, import PySpark.sql.functions as f. Let's do define post users, one big table, accepts stage post df data frame, and accepts raw users df data frame, and outputs a data frame. Over here, I'm going to return staging post df alias post. Let's rename some columns. So with column rename, let's rename creation date to post creation date. And let's join it with raw users df. Rename some columns too. So with column rename creation date, user creation date, and alias it as users. We'll specify the key to join the table. So let's do f.call post.owner user ID equals f.call users.id. And let's do an inner join. So this looks good. Actually, let's do a left join. Let's do a left join. Marts post users df equals post users one big table, and let's pass in these data frames. Let's go ahead and run this and save it as a table, post users. And let's double check our data. So let's create one more marts table. So let's create one more table called go most popular tags. Stage post df equals spark.table default.stage post. And in this notebook, I just want to calculate what are the top tags using the array of tags that we computed in the staging layer here. So let's copy paste some code. Let's copy paste this. Define post top tags, accept stage post df data frame, outputs a data frame, and let's return stage post df with column. So we'll create a new column. Let's call it tag exploded, and let's f.explode tags array. After we explode the tags, let's group by tag exploded, and let's aggregate the value. So let's do approx count distinct. So approx count distinct is just a fuzzy way of doing count distinct, and it's a lot faster. Let's do post ID alias tags count. And then let's do order by f.call tags count dot descending. Marts top tags df equals post top tags staging post.df. And let's save the table as marts top tags. Oh, whoops, typo. Run this again. Okay, very nice. So It turns out that neural networks is the most popular tag. If you made it this far, congrats on making it this far. We've completed our data transformations. Let's just pause here and just reflect on what we've done. So we've created a bunch of notebooks and we've layered them in terms of bronze, silver, and gold. So we have this bronze post that is just reading files and ingesting it into a raw table. Same for bronze users. We're just reading the file, just getting the schema, and this schema will help us check for schema changes and just doing some light processing, saving it to a raw location. After we have our raw tables, we created this data quality check layer that basically uses this library called DQX to run a bunch of checks. And DQX is nice because it gives us this quarantine data frame. And in this silver post, this is where we do the bulk of our transformations and business logic. And in silver post, we write our transformations in a declarative way. Instead of writing the transformations, it's a lot easier to maintain if we write these declarative functions and chain them together at the bottom. So this is a much easier way to write transformations. We have this gold layer here that generates a post users one big table, and a gold layer here that generates the posts for the top tags. And if I go to the catalog here, click on my schema, you can see different tables. So this is good. The last thing I want to do is to create a dashboard. So let's create a dashboard right now. Let's create a dashboard. And I'm going to do data. Oh, whoops. Let's call it my dashboard 2. I'm going to add a data source. Let's go to data platform tutorial default. Let's add this one, this one. Yeah, let's add these two to confirm. Let's rename this to post and users. And let's create some dashboards. Okay, for here, for Mart's top tags, I'm going to limit to 10 only. Okay, over here, let's click on add visualization. I'll create a box here. Let's use Mart's post users. Let's create a line chart. And for the x-axis, let's do post creation date. And for the y-axis, post ID. Whoops, let's do the count of the post ID. So we can see here for this Stack Exchange page, the number of posts for AI peaked at around April 2020. So this is pretty cool. Let's create one more chart here. We can do something like this. We can do Mart's top tags. Let's do a bar chart. For the x-axis, we can use tag exploded. And then for the y-axis, let's do sum of tags count. Yeah, and then for the x-axis, let's organize it, the y-axis from descending order here. So this looks good. And we can create one more chart here. So let's do one more. Maybe you can make something like this. So this time I want to use a scatter plot. I'm going to go back to data. Let's create from SQL. Let's do something like select star from default.marts post users, where post type equals answer. And let's group by ID and reputation. Let's get the sum of the score, the reputation, and the ID. So I'm trying to find out the relationship between whether, okay, as user ID. Okay, I'm trying to find out the relationship between if a user has a high reputation, what is their average score? Let's say, okay, let's use average. Average answer score. Let's go here. Let's do reputation for x-axis, and let's do average answer score. Interesting. So it turns out that if you have a high reputation on a Stack Exchange, it doesn't mean that you might have a good answer score. So this might be skewed because maybe users who don't have a high reputation, maybe they don't post a lot, and for those few posts that they generated, they do very well. But there's kind of a weird trend here where there's one line going like this and the other line going upward. So you can see there is some kind of relationship between reputation and average answer score, but not quite. So this is an interesting pattern. So we've generated some dashboards, some charts for users to see. We have a bunch of notebooks. Let's automate everything in Databricks workflows. So I'm going to click publish and click publish. So I publish my dashboard like this. Okay. And let's go to jobs and pipelines and click on job. Over here, let's call this my workflows. Let's call it my workflows. Let's call this bronze post. It's a type notebook. Let's select the notebook from here. Yeah, let's select the notebook. I'm going to select bronze post. And this will use my cluster. Create task. Let's create another notebook. Let's call it bronze post DQX, which is the data quality check. I'm just going to quickly fill this out, but you get the gist of it. Select compute, create task. Let me just zoom out so you can see. The last one I want to create is dashboard. So let's do dashboard post users. Okay, so this is what you should get. Bronze post to bronze post DQX to silver post, bronze users. Gold post is a combination of bronze users and silver posts. Gold top tags is coming from silver posts. And then dashboard, wait, I think this is wrong. So dashboard post users should come from both gold post users and gold post tags. Okay, yeah, so this looks correct now. So dashboard is coming from both the gold layer here. Once you have this workflows all set up, you can create a schedule if you want. So you can add a schedule. You can do schedule, run this every day, save it. So let's go ahead and trigger the run. So let's click run now. And I'm just gonna wait for this to complete. Okay, so this is running right now. Oh, okay, it looks like there's an issue. Let's see why. Oh, whoops. I need to comment this out. Okay, I need to comment these lines out very quickly. So let me just comment this line out again. Oh, whoops. Oh, okay. Let me comment this out again. Okay, so I've commented out the lines. Let's rerun it again. So click run now. So this should work. Okay, nice. So everything's working. So congrats, we're done with the first part. We've finished with part 1, and let's just save our notebooks into GitHub. So let's go to workspace. Let's create a Git folder. And I'm going to create a Git repo. Yeah, so let me just create a Git repo. Let's call it Databricks Airflow 3.0 template. Let's set this to private for now. Let's create a repo. So I'm going to quickly link my Git account. It says I have to go to this website to install the app to link my account. So let me just quickly do that. Yeah, so let's click Databricks Airflow 3.0 template, click Save. Try again. And this should work. Okay, it works. Nice. So over here, I'm gonna create a folder. Let's call it notebooks. And then I'm just gonna copy paste everything into notebooks. Yeah, copy paste these into notebooks. Okay, so let's push the changes to the branch. Let's do feature add Databricks notebooks. Commit and push. Oh yeah, one more thing is to make sure you update your workflows to use the new directories. Yeah, so just go ahead and quickly update all your notebooks to use the new paths. You should see your files here, so notebooks. See bronze post, bronze users, gold, most popular tags, post users, silver posts. So congrats, we're done with part 1. I'm gonna pause the video here and we'll do part 2. This section is going to be a lot more software engineering focused, where we'll be deploying Airflow 3.0 using Kubernetes and look into some newer features in Airflow, such as data assets and DAG versioning. Data assets is a new way of defining DAGs in a declarative approach using this asset syntax. And what this means is basically it's a shorthand way of creating one DAG with one task associated that produces one asset. An asset could be a S3 file, it could be a Postgres table, but basically this allows us to create DAGs in an asset-oriented approach. So previously with a task-oriented approach, people would write individual functions that perform one task only. So you would write a function to extract data, you write another task to transform data, load it to a data warehouse. But with the asset-based approach, you can define how you want your data to look like and pass it on to other assets. So over here, you're creating an asset for extracted data and you're passing it to the schedule. That way, every time extracted data is reloaded, this downstream DAG is going to run again. So this is called data-aware scheduling. Let's go back here to the slides. I also wanted to talk about nitty-gritty stuff, such as how to create a custom Docker image that packages our Airflow deployment. And we'll look into how to configure Helm charts for our Kubernetes deployment. So Helm charts is just is a recipe that allows you to template Kubernetes deployment. And this is the official Helm chart version. It looks like the latest version is 1.18. So this was updated a few days ago. So I also wanted to preface this by saying this section might be a bit challenging if you're new to containers in Airflow. If you get stuck, the code base is right here. I'm going to link this in the description below. I've tried my best to split up the code base in a way that there are checkpoints, so in case you get stuck, you can always revisit the previous checkpoint. Now, there are many ways you can deploy Airflow. Astronomer is one of the most popular ways that allows you to have managed service for Airflow. They can be quite expensive, and I know there's a lot of news about Astronomer lately because of the Coldplay concert, but they actually have a pretty amazing product, so please go check that out. The other way you could deploy Airflow is using Airflow Docker Compose. Yeah, so this is the other way you can deploy Airflow using Docker Compose. This method is probably easier if you work in a small company and you don't need to scale it to thousands of users. But for this video, we'll stick with Kubernetes. For prerequisites, you'll need two things. You'll need Docker setup. So make sure to go to docker.com and download Docker, get Docker desktop. So I already have Docker ready right here. So I already have Docker desktop right here. The second thing you need for this section is Kine. So what is Kine? Kine is a way to run Kubernetes locally. So Kine is a tool primarily for running local Kubernetes clusters using Docker container nodes. And it was designed for testing Kubernetes in local development. And what's nice about Kine is that whatever you can run on Kine, you can guarantee that it's going to work in production. So go ahead and click on Quick Start, Installation, scroll down. If you're using a MacBook, you can install Kind using brew. If you're using Linux or Windows, if you're using Linux, you can install Kind using the scripts here. Just copy paste it. So once you have Kind and Docker Desktop all set up, I'll do a very short intro to what Kubernetes is. So for those of you who don't know, Kubernetes is a way to orchestrate containers, and each container is going to be represented by a pod. So what does that mean? So I've put together this like 1-minute intro to Kubernetes. So once you have Kind installed, I'm going to create a Kind cluster here. So I'm going to do Kind create cluster image. So I'm going to create a Kind cluster. Once you create a Kind cluster, if I go back to Docker Desktop, you can see that I have a container that's running, which is the Kind control plane. So this is going to represent your Kubernetes local cluster. So what are pods? Let's take a look at. Oops. So Kubernetes work by deploying pods, and pods are the smallest deployable units of computing that you can create in Kubernetes. You can think of it as a group of one or more containers, but typically people would allocate one container for one pod. And with pods, you can have things such as shared storage and network resources. You can specify how you want to run the container. The way you define pods is using this syntax. You need to specify an API version, the kind, which is a pod, some metadata, and the specs. So the way you would read these pod YAML manifest file is you look at 4 things: the API version, the kind, metadata, and spec. So I won't go too much into detail, but let's take a look at a very simple container. So this is a very simple pod that essentially, the pod's name is sleep pod, and I'm going to create a namespace called my namespace. And this pod is going to echo hello world and sleep for 5 minutes. So let me go back here. The first thing I need to do is to create a namespace. And the reason why you need to create a namespace is because there are different namespaces for different applications. So for kube system, there's a system namespace for all your Kind clusters or your deployments. So typically you would create one namespace per application. So let's go ahead and create a namespace. Since my namespace is created. And the way you would create pods is using kubectl apply -f pod.yaml. So this is going to create a pod. It says the pod is created. So after it's created, how do we know it's created? Let's verify it by getting all pods. So you can get all the pods in this namespace by doing kubectl get pods my namespace. You can see sleep pod is running right now. If you want to debug and inspect pods, you can do kubectl describe pod sleep pod. Yeah, so you can inspect the pod. You can see that, oh, this pod was successfully created, and it's using this busybox image with image ID. You could also inspect the logs, so do kubectl logs sleep pod, and we can see hello world. If you want to delete a pod, run kubectl delete pod sleep pod. Okay, so now it's deleted. Let me go ahead and delete my Kind cluster so we can restart this. So yeah, these are very basic commands for how to use kubectl. I'm just gonna go ahead and delete these 2 files. Now, let's install Airflow. So to install Airflow, I'm going to create a script here. Let's call it install Airflow here, like this. Let me chmod install Airflow. And first thing to do is to create or replace a Kind cluster. So Kind delete cluster, Kind create cluster. So let's go ahead and create a cluster, copy paste. While this is being created, I'm going to add Airflow to my helm repo. So let's do helm repo at Apache Airflow and copy paste the Apache Airflow website here. And I'll do helm repo update helm. So what this means is I need to add my Apache Airflow into my repo, and I'm going to run a helm repo update in case this Airflow repo has any updates. Okay. So let me just run this. So it looks like I already added it, so it's not doing anything. The other thing I wanted to do is to run helm show values Apache Airflow, and to chart values.example.yaml. Let's go ahead and copy this. Oh, whoops. This is going to show the values in my Helm chart and output it to this file here. Now, why did I want this file? This file is basically a template that allows you to configure your Airflow versions. It allows you to configure your images, your workers, your ingress, your networking. I'm not going to use this example file specifically, but this is very important to know. We won't be using this file specifically, but this will be very important for us to reference in the future. So yeah, just a heads up. Yeah, you can see that right now it's using Airflow 3.0.2, and it's using the Apache Airflow repository here. So let's go back. I'm going to export values for Airflow Docker images. And let me do export image name. Let me call my image mydax. Export image tag. So tag is usually something like semantic versioning. It could be 0.0.1, 0.2, 0.3. But I'm going to do something simple. I'm going to do date plus. Okay, it looks like Copilot is giving me the right one. So I'm just going to put my image tag as the year, month, date, hour, minutes, seconds. Obviously, you shouldn't do this in production, but for the sake of this video, this is probably the easiest way that I can create image tags without having to think about a version. I'm also going to export the namespace. So namespace is what I talked about briefly in Kubernetes. So let me call my application Airflow. I'm also going to export the release name, and this is going to be Airflow. So let's go ahead and run this, export these values. Next thing to do is let's create a Docker image. So I'll create a CI/CD folder here and create a Docker file. This Docker file is going to represent our deployment of Airflow image. So I need to go to the Airflow Docker images. So let's go to Docker Hub and find the specific Airflow version that I want. Okay, let's see. Slim latest, not really. Okay, found it. All right, I'm going to use 3.0.2 Python 3.11. So let's copy paste this. Go back here from Apache Airflow and copy paste the version. 3.0.2 Python 0.11. Save this in your Docker file. Let's go back to install script here. And let's build the image and load it into Kind. So Docker build pull tag image name image tag -f CI/CD Docker file dot. So this is going to build the image and load it into Kind. And the second thing we need to do is to run kind load docker image, copy paste. Kind load Docker image is going to pull this image that we just built and load it into our local kind cluster. Okay, for this demo, let me just specify the tag as 0.01 just to show you. So I'm just going to copy paste this. Then let's do Docker build. Okay, it looks like my container is finished building. And let's load it into kind. Once your image is loaded into kind, let's go ahead and create a namespace. So let's do kubectl create namespace and put your namespace here and install Airflow using Helm. To install Airflow, we'll do helm install release name. So this is the name of your release, Apache Airflow. And I need to set my namespace. So let's do namespace. And I need to specify a few things. If I just run this command, it's going to pull all the values from values.example. But I want to customize this such a way that I want to specify the image being used to be this custom Docker image. So how can I do that? So I'm going to go here, just going to copy paste images here. And let's create a new file called values-override.yaml and paste this here. Once I paste this, I'm going to rename repo to my.dags. So my.dags is the image that we just created here in this step here, Docker build. Just to clarify, I just copy pasted this, put it here, and my.dags is the image that I just loaded into my kind cluster. So once I have this values-override, let's do -f chart-values-override. This is going to use these values instead. So whatever values here that I specify is going to override the existing ones on top of the example Helm chart here. Okay. One more thing I need to do is set string images.airflow.tag. So set string images.airflow.tag is setting my tag to 0.0.1. Why do I need this? If I don't specify this, it's currently going to pull the latest tag or the default tag here because I didn't specify it. But because every time I rebuild my image, I'm going to create a new tag, I want to pass it here as a string instead. That way I can be more dynamic in terms of how I release my Airflow deployments. So this is very important here, this set string parameter. Last thing to do is --debug. So --debug is to allow your Helm command to be more verbose. So when you run Helm install, it's just going to get stuck there for a few minutes and there's no way to know that how your deployment is going. It really helps with your debugging process. So let's go ahead and create my namespace first. And let's install Airflow. So this is going to take a few minutes to run. Because we set this debug flag, we can see all the messages here. Okay, this might take a few minutes. Okay, it's done. So it says, okay, this is great. Thank you for installing Apache Airflow 3.0.2. You have your API server ready. Here's your web server username and password. The username is admin, the password is admin. So you need to port forward the current Airflow API server to your local host. So that's the last step we need. So port forward the API server. So let's do kubectl, copy paste this. Let me just rename this to release name. Okay. And rename this to namespace. So once you do this, let's kubectl port forward the web server. And you can see it's forwarding it to port 8080. And let's go to localhost 8080. Username is admin, password is admin. Okay, well done. This is the new Airflow 3.0 UI. So congrats, you've just successfully deployed Airflow on Kubernetes. This is what the UI looks like. You can see immediately it's a huge improvement from Airflow 2.0. So the first homepage is going to tell you kind of a summary of the DAGs that are currently running, success, failure. You can see DAGs here. So DAGs, you can check, like there's two views for DAGs in the list format or grid format. There's a tab for assets, browse, audit log, XCOM. So these are old features. Admin, you can check for connections, variables, pools, providers. So by default, Airflow is going to give you packages for AWS. Also gives you stuff like Git, MySQL, Postgres. Okay, so let's go back to our console. If I create a new console here, and if let's do kubectl get all -n Airflow. So this command is going to get all the pods, services, deployments, replica sets, storages for our Airflow namespace. If I do kubectl get all -airflow, you can see, okay, there are currently 8 pods running for Airflow. We have our API server, we have our Airflow worker, we have a DAG processor that parses our DAG files, we have a pod for Postgres, Redis, scheduler, statsd, triggerer. We also have a bunch of services here for our API servers, Postgres. You don't need to know too much about what replica sets, deployments, stateful sets are, but this is good awareness to know that, okay, whenever you run helm install, it's going to produce a bunch of these artifacts for you. So now how can I add DAGs into my Airflow deployment? So let's go ahead and do that. So let's go ahead and create a DAGs folder. So I'll create a new folder. Let's call it DAGs. So let's create a new folder called DAGs. And example dag.py. Example dag.py is going to have a couple of libraries: import datetime, import from airflow.sdk, import dag, and task, import time. Let's do with dag. Dag ID equals example dag. Start date equals date time dot date time 2021 1. Schedule, let's do daily. And let's create a task. So task define hello world. So this task is going to sleep for 5 seconds. It's just going to print hello world from Airflow. Okay, so a very basic example DAG. Now I need to bake in this DAGs file into my Airflow image. So how can I do that? Go to Docker, go to your Docker file, and let's do copy.dags into /opt airflow/dags. This is going to copy the contents of your DAGs folder into /opt/airflow/dags, which is the location in your container that mounts the DAGs. So this copy dags opt airflow dags is going to copy your DAGs folder here with your example DAG into this folder, which lives inside your Airflow container. So once you have this, now I need a way to upgrade my Airflow deployment in order to rebuild this Docker image and redeploy my Helm deployment. Let's create upgrade Airflow. Let's do chmod upgrade Airflow. I'm just going to copy paste some stuff here from install Airflow. Copy paste the export script and copy paste your Docker build and Docker load, your kind load Docker image commands. Let's also copy paste this helm install command. Instead of install, let's do upgrade. And let's swap install with upgrade. And let's also copy paste this port forward script here. This way, every time you want to redeploy Airflow, you can just run this upgrade Airflow script. So let's go ahead and do that. Let's do upgrade Airflow. Wait a couple minutes for this to finish running. Let's go back to Airflow, go to localhost 8080. Oh, whoops. Looks like the connection broke. Let's port forward again. Let's go to admin, click on DAGs, and we can see example DAG is running. When we click on example DAG, it's going to give you a task that says hello world. You can see that the latest DAG version is v1. So every time you change the version of your DAG, it's going to get upgraded automatically to v2, v3. Okay, click trigger. So this is going to trigger hello world. Click on the task, click info. It says hello world from Airflow. Let's go ahead and create our DAGs for our Databricks project. So I'm just going to close all these tabs here to clean up. Let's go back to Databricks here. Okay. In part 1 of the tutorial, we created this Databricks workflows that extracts data from posts and users and creates a couple of tables downstream, creates a dashboard, creates posts and users, creates GOAT top tags. Now let's create some Airflow DAGs to automate this process and also automate this part, which is getting the raw data. So in the first part, we essentially had to read data from a managed volume that we created called my volume, and we had to read this post file. So let's use Airflow to automate this step. Let's automate the ingestion process. So over here, remember, this is the website we used to download the Stack Exchange files. We would click on this file. So let's go back here. So let's create a new DAG. Let's call it produce data assets. In produce data assets, I'm going to import a bunch of libraries. Import OS. So I'm just gonna copy paste a bunch of libraries for logging. So this library pi7zr is just to unzip the file, because if you click download on here, it's gonna give you a zip file here. So I need a way to unzip it. Let's get Airflow providers, Amazon S3 hook. So over here, I'm going to create post asset equals asset. Okay, so for post assets, I've gone ahead and created a new bucket in S3 called data platform tutorial. And I'm just going to copy paste this S3 bucket here. And let's call it raw post.xml. Let's do the same thing for the users file. So users asset equals asset. Copy paste this. Let's call it users. And let's go ahead and create our assets. So let's do define produce data assets. And let's call this one asset. Key equals, this is the file that we want to download, and the URL. So the URL that we want to download is here, /key. Let's create an output path. So I'm just specifying a bunch of variables to download files and where to unzip it. So let's actually download it. Download the file. Let's do logging.info, downloading URL. Response equals request.get. Let's do with open output path as file. Just write the file to the output path location. Once you download the file, let's extract it. Let's extract the zip files with pi7zr 7-zip file output path mode r as archive. Let's do archive extract all path equals extract path. Last one is to load the file to S3. Let's do S3 hook equals S3 hook AWS con ID equals AWS con. So we need to create this variable, this connection in Airflow. We don't have AWS con yet, and we need to create this in the UI. Let's do post file equals os.path.join extract path post XML. And let's just upload the files using the S3 hook. So S3 hook dot load file. The file name is post file. The key is going to be raw post.xml. The bucket name is going to be data platform tutorial. And then replace equals true. Copy paste this. Copy paste this. Users file. Let's rename this to users. I want to load my unzipped files into S3. So really simple. So this asset here, I want to produce two different assets. I believe you can do this using a multi-decorator. So let's see. Okay, yeah. So if you want to output to multiple assets in one task, yeah, so you should be able to create multiple assets using this syntax, asset.multi. So let's do asset.multi schedule equals daily and outlets equals post assets and users asset. So I'm just copy pasting this here. So this is how you would define your asset. So let's go ahead and run this again. Let's do upgrade Airflow and wait a few minutes for this to deploy. Okay, once it's finished upgrading, let's go back to Airflow. Hit refresh. Oh, whoops. Looks like my port forward disconnected for some reason. Okay, let's go back to Airflow. Admin, click on DAX, and it seems that there's an error. Aha, so let's take a look. It says module not found error, no module pi7zr. So it seems like our Airflow Docker image doesn't have this library. How can we fix this? Think about this for a few seconds. This fix is relatively simple. So all we need to do is go here and let's create a file called requirements.txt. In requirements.txt, let's add pi7zr. Let's add a specific version. So this is the latest version for pi7zr to unzip our file. And then the other thing we need to do is go to our Docker file and let's do copy requirements.txt dot. And let's do run pip install no cache dir. So let's copy this requirements.txt file into our container and let's run pip install. So once we have this, let's kill our connection again and let's do upgrade. So this should work. Okay, now our Airflow server is running. Let's go back to localhost. Click on DAX. Whoops. Let's port forward. Let's go back to Airflow, log in again, click on DAGs. And okay, now we see a DAG called produce data assets. If you click on produce data assets, okay, and you can see produce data assets here. You can click on assets, and now we can see S3 data platform tutorial, raw post XML, and users XML. So it looks like there's a typo here. So let me just quickly fix this. Okay, let me fix this typo. It should be capital users. In order to run this DAG, we need to create a connection for this S3 hook here. So AWS con ID. So go to admin, go to connections, click add connections, and go to AWS. Let's call your connection ID AWS con, and add your AWS access key or secret access key. So you can get this by going to your IAM, okay, so go to your users, create an IAM user, go to security credentials, and create an access key here. So once you create an access key, click other, next. Make sure to save this somewhere and don't share this with other people. So I'm going to delete my access key after I'm done. Okay. Go back here. So I'm going to quickly copy paste my access key. And click save. So once I click save, let's go back to DAX, click on produce data assets, click trigger. So it looks like produce data assets was able to run successfully. You can click on the asset run here, click on this little green line, and we can see that produce data assets was able to download the file from this archive website into this local directory. It's able to extract the zip file to a folder, and is able to fetch the AWS connection that we just set up in our Airflow connections. So this, everything works. We can even verify that our data lives in our S3 bucket. So go to your S3 bucket that you just created. And you can see that the files for posts and users is here. So this is great. This is exactly what we want. So once we have this, you can click on assets. You can see S3 data platform tutorial raw post. This creates an asset event, and an asset event is what tells a downstream DAG that, hey, this data is refreshed and it's ready to materialize any downstream DAGs that depend on this data asset. That way you don't have to manually write cron schedules to materialize DAGs. You can just link together multiple DAGs to this asset. That way every time posts change, downstream DAGs will also automatically be updated. So yeah, if I click on here, you can see there are 2 created asset events in total, and it's created for S3 posts and S3 users. So now that we have posts and users, how can we take these files and connect it back to our Databricks workflows? So remember in part 1, we created this workflows here, and this workflows is essentially chaining together a bunch of notebooks to create a dashboard and a bunch of data marts. In my bronze layer here for posts and users, these are, let me take a look. So these bronze layers, if we scroll down, is basically trying to load from this volume path. It's loading from a managed volume called my volume, and I'm fetching this post. So how can I connect the dots? How can I connect these files into these load locations? So go to catalog default. Over here, if I click on default, click create, I'm going to click volume. Now, I'm going to create my external volume and click external volume. You might not have this feature if you're using the free version of Databricks. You can skip this step if you're using the free version. I don't think it matters so much, but just to show you guys how I would download data, load it into some kind of S3 bucket, mount that S3 bucket into Databricks so that Databricks can create notebooks to fetch those data sets. So click on external location and click create new external location. So this is going to essentially create a CloudFormation template in AWS that helps you set up your external mount. So I've already done this, so I'm just gonna like skip this step. Yeah, so you would write something like S3 my external mount bucket. Generate a personal access token, copy paste this, click launch, and you basically just need to paste in your Databricks personal access token to create a CloudFormation template. So this CloudFormation template is going to spin up a S3 external storage for you. Hit create stack. I've already done this, so let me just go back here. So once you've done that, you should get something like this. So I've created my external volume, and over here, my external volume, you can check out this raw folder, and raw folder contains posts and users, and this was modified 30 minutes ago over here. So these files are the same as this one in my external volume. Once I have this, let me go back to my workflows and update my bronze and users notebooks. So let me just go back here to bronze post. And I'm just going to update this to my external volume. Let me do the same thing for bronze users. Click here. And let's update my volume to my external volume. If you're using the free version, you can just leave this be. This is just to show you how I would do it. So let's go ahead and trigger this workflows through Airflow. Let's go back here. Let's add one more DAG. Let's call it trigger Databricks workflow dag.py. And trigger Databricks dag.py, let's import. Let me import from airflow.sdk, import DAG from airflow.providers.databricks.operators.databricks. Let's import Databricks run now operator. Okay. So this Databricks run now operator is basically allows you to run an existing Spark job using the API. And you basically just need to pass in the job ID. One more thing I want to import is from DAX produce data assets. Let's import posts asset and users asset. So let me just import the assets that I created here. Let's go back here with DAG ID. Let's call it trigger Databricks workflow schedule. Okay, so instead of writing a cron schedule here, instead of doing something like, oh, run it daily, I'm going to pass in post asset and users asset. So this will allow me to perform data aware scheduling. So that means every time posts or users is refreshed, my schedule will automatically materialize, and this DAG will automatically be triggered. So this is what it means. I'm not using a regular cron schedule. I'm just passing in the data assets into my schedule. Okay, let's create a operator. Let's run the operator. Let's do run Databricks workflow equals this one, task ID. Let's call it run Databricks workflow again. Okay, so for this Databricks con ID, I need to create this. So I'm just going to write Databricks con, and we're going to create this later in Airflow, the same way we created our AWS con. For job ID, now where can we find this job ID? If you go back to workflows, on the right hand side, you can see job ID here. So I'm going to click copy and paste the job ID. So this is it. Produce data assets produces posts and users, and trigger Databricks workflow DAG will only run once post users and users assets get triggered. So let's go ahead and upgrade let's do upgrade. To create a connection ID, I need to get some personal secret tokens first. So go to settings, click on developer, and click on access tokens. Click manage and generate a new token. So you can call your token my new token. You can generate one and just save this, copy paste it somewhere. Make sure you keep this for yourself only. Don't share this with other people. I'll copy paste this somewhere. Click done. Okay. Once I have my token, let's wait for Airflow to finish deploying. Let's go back to localhost. Oops. I'm not sure why my port forward connection keeps breaking, but I'll show you a way to avoid this later. So let me just quickly port forward. Go back to Airflow. Go back to DAX. Okay, looks like there's an error. It says no module name Airflow providers Databricks. So it looks like I need to install Databricks. So let me just copy paste this. Okay, it seems like the latest version is 7.6.0. So let's go ahead and copy paste this. Go to requirements, paste this, 7.6.0. Save it. Oh, one more thing is you need to create an init file here and make sure to add Apache Airflow Databricks here before you hit upgrade Airflow. So yeah, let's just remove DAX in produce data assets and create an init file. So your code should look something like this, and let's run upgrade Airflow. Like this is working. We have trigger Databricks workflow DAG. So make sure your trigger Databricks workflow DAG looks like this. You have from produce data assets, import post assets, users assets, and make sure you create this init file here. That way it lets Python know that this is a directory, and you can just do produce data assets, import post assets, users assets. This looks good. Okay, so once you have your DAG set up for produce data assets, users, post asset, and trigger Databricks workflow DAG, let's go ahead and run this. And let me just double check if my pipeline looks good. So if I go to my task, click here, I just want to make sure my cluster is running. If you're using the free version, you can just use a serverless one if you're using a free version. But let me just double check if everything looks good. Okay, everything looks good. Let's click here and hit trigger. So this is going to download the files, fetch it, and load it into S3 directly. Our S3 folder is already mounted using an external mount in Databricks. Our assets is going to be refreshed. Oh, one more thing. I need to trigger. Okay, I forgot to turn on this DAG, so it's not going to work if I don't turn this on. So let's try that again. Trigger. Trigger. Okay, this is connection not found Databricks con. So that's because I haven't added my connection yet. So let's go ahead and add that. Is that a connection? Let's go to Databricks. Let's add Databricks con. In host, you are going to copy paste your host name here. Paste it here. And then for password, you need to copy paste the personal access token here for password. And this is it. This should work. So let's try that again. Produce data assets, trigger, run. And it's triggering a DAG. So this is good. It's running everything on Databricks. You can click here to see your workflows, and looks like it's running successfully. Okay, this is amazing. This means we have successfully set up an end-to-end pipeline that is able to download files from some kind of API, fetch it locally, store it in an S3 bucket, create asset events, and these assets are going to trigger a run here in Run Databricks workflow. And Databricks workflow is going to generate some dashboards. Okay, why is it failing? Okay, it says path does not exist. Let me just check. Copy path. Okay, this is my bad. It should be my external volume raw post. So you should update this to volumes data platform tutorial default my external volume raw post. If you're using the free version, you don't have to update this. And let me copy paste this again and upload it to the other notebook. Yeah, so let me quickly update this. Users. Save and hit trigger again. I'm just going to pause the video and I'll come back in a few minutes. It looks like the workflow has completed. So amazing job. You've successfully created your first end-to-end pipeline using Airflow on Kubernetes on Databricks. Let's go back to the code base here. Now, if I click on values-example, and let's look up the word executor. If I search up the word executor, it says it's currently using the celery executor. This means that whatever task that we generated in Airflow so far isn't using Kubernetes yet. So if we click on example DAG, all these tasks are currently being executed on a celery executor. It's not being run on Kubernetes. There are a bunch of different types of executors in Airflow. So you can click on this link here. There's local executor, celery executor, but the one we're looking for is Kubernetes executor. So let's go ahead and grab this guy, go to values override. Let's copy paste this, and let's replace this with Kubernetes executor. Once you replace this to Kubernetes executor, I'm also going to do a couple things. I'm going to add a feature that allows you to sync your DAG folder from Git into your Airflow deployment. And the reason you will want this is because right now it's kind of annoying to always, every time you make changes to your DAGs, let's say if I add a new task here, task, goodbye world, I would have to rerun upgrade Airflow, rebuild my Docker image. It's very slow, and it's also not the right approach. So instead of doing that, I'm going to create something called Git-sync. And in order to do Git-sync, I'm going to go to values.example. Let me search out the word Git-sync. Let me copy paste this one. It says DAX Git-sync. I'm going to copy paste this one. Go to values.override. Let's do DAX, paste, Git-sync. Let's change enable to true. So setting Git-sync enabled to true is going to create something called a sidecar container. So Git-sync sidecar. It's going to create a sidecar app that essentially pulls files from a repository so that an application can consume them. So this is the repo for Git-sync. Yeah, so Git-sync is a simple command that pulls a Git repo into local directory. And if the remote repo changes, those changes will be synced locally. It's a perfect sidecar container in Kubernetes. So once I have this, let me enable this to true. And let me do one more thing. I'm going to change the subpath to just dags. Let me change this to main. Let me change my branch. Whoops. Let me change my branch to my current branch, which is feature/demo. And for the repo, I'm going to copy paste my repo in GitHub. So let's see. Yeah, this is my GitHub repo. I'm just gonna go here, copy paste this, paste it here. And one last thing is I need a credentials. So I'm gonna put git credentials. I need to create a secret in Kubernetes in order to apply Git-sync. In order to create a secret, let me create a folder called K8s. Let's create another folder called secrets. Let's create git secrets.yaml. Then over here, I'm going to create a kind, which is a secret, some metadata. I'm going to call this name git credentials. So git credentials is going to match this credential secret here. This value must match this name here. I'm also going to add namespace. Let's call it airflow. And lastly, I need to add 4 things, which is the git-sync username, git-sync password. I forgot which parameters I need for git-sync. I'm just going to add everything for username and password. So in order to get my git-sync username and git-sync password, I'm going to my GitHub account, click on settings, scroll down, click on developer settings, click on personal access token. So click generate token, click on generate new token classic, and click on my git sync token. Click on repo, generate token. Once you have the token, so this is my token, I'm going to go ahead and encode this. So I'm going to do echo -n, type in your token, and then base 64. So this is going to generate the password for you. And then go ahead and do that for your username. So echo -n, this is my username, base 64. And this is my username. So this is how you would generate the Git-sync token. This is how you would generate the Git-sync token. I would create a personal access token here, copy paste the token, echo -n, paste your token here, and then type base 64. I'm basically encoding the password in my username, pasting it here. For production, obviously you don't want to copy paste your username password, but this will work for a demo. Once I have this, go back to install Airflow, and I'm going to add one line here that says apply Kubernetes secrets. So let's do kubectl apply -f k8s secrets git secrets. So let me go ahead and create my secret, and let me upgrade Airflow. So let's go ahead and upgrade Airflow. So now you should have the Kubernetes executor, and we should have this Git-sync ready. So let's do this. Go back to Airflow. I'm going to try and make a change now and push it to this repo. So let's do something like this. Let's modify example DAG. Let's add a task. Goodbye world. And let's update our DAG here. I'm just going to do git add, git commit, update my DAG. And we'll do push. Okay, now that we pushed it, let's go back to the branch. And it looks like we have some code in our branch now. Let's see. Click on DAGs. We can see example DAG has a new task. Okay, so this is cool. We just push code to Git, and we didn't have to run an upgrade Airflow. The new code that was added to this example was already added here. We can see task def goodbye world, print goodbye world. We can see these new tasks. So if we click trigger, it's working. So this is very cool. We didn't have to redeploy our Airflow DAG again. We only needed to push a Git, and using our sidecar container, Git-sync is able to link this DAGs repo with our Airflow deployment. If I click on each task, if I click on logs, now everything is running on Kubernetes. So if I click trigger again and go back to my console, and let's type something like kubectl get pods -n Airflow. Now you can see example DAG hello world is currently running. If I do something like this, yeah, so example DAG goodbye world is running right now. So this is the task that's running. The moment the task finishes running, if I run kubectl get pods again, you can see that, oh wait, what happened to my task? This disappeared. So whatever task created using this Kubernetes executor is going to be ephemeral. It's going to be short-lived. As soon as the task finishes, the pod will automatically delete. So that's why it means to be ephemeral. If I go back here and I click on logs, I can't see the logs anymore. Because your pods are ephemeral, they're non-persistent. So the question is, how can we make this logs persistent? That's what we're going to tackle next. How can we see logs here after our pod is running? So everything is running on Kubernetes now. If I go back here, let's create a new chart. So copy paste this values override, copy paste. And let me rename this to dash persistence. Same thing here, I'm going to install Airflow, copy paste. And let's call it install Airflow with persistence. There are a couple things I need to do to set up persistence in Airflow logging. If I click on values example, let's look up logging. Go to values.example, let's go to logging, and I'll copy paste this file here. Copy paste this code. I'm going to paste this here, and this time I'm going to enable persistence to true. For my storage class name, I'm going to create a custom storage class. Let's call this manual. I don't think I need to specify this one or this. And for existing claim, let's call it airflow-logs-pvc. So an existing claim is your persistent volume claim. So what is a persistent volume claim? A persistent volume claim or persistent volume is a piece of storage in your cluster that's provisioned by using storage classes. It is a resource in your cluster, just like a node, and they are sort of like plugins for volumes. Whereas a persistent volume claim is a request for the storage by user. So in order to request a volume, you first need to create a a PVC, a persistent volume claim, link it together with a persistent volume. So this is very important. So TLDR is a PVC allows you to request for storage by user, and a persistent volume is a piece of storage that allows you to mount data in a persistent way. So let's go ahead and do that. In my Kubernetes folder, let's create something called volumes. And I'm going to create airflow logs PVC -YAML. In airflow logs PVC, I'm going to specify an API version, which is v1. For the kind, I'll create a persistent volume claim. For metadata, let's create airflow logs PVC. For namespace, let's use airflow. For spec, I'm going to put my storage class name, manual. So this manual here has to match the manual storage class. Otherwise, the persistent volume claim can bind to airflow. For access modes, let's do read, write many. For resources, let's request storage of 5 gigs. Okay, this looks good. Let's create one more file called airflow logs-pv. And this is going to be API version v1, kind, persistent volume, metadata, name, airflow logs pv, spec. So I need to specify my storage class, set this as manual. For capacity, storage 5 gigs. Access modes, let's use read write many. And for host path, so the host path is the path on the container host where logs will be stored. So my host path, let me create a path. Let's call it mount airflow data logs. So this is the path that is in your container host where you want to write logs to, right? So I have a PVC, I have a persistent volume here. And let me upgrade my script here. Let me update my script. Let's go back to install airflow. Let's add kubectl apply -f volumes airflow logs pv YAML, and copy paste this and kubectl apply airflow logs pvc. So this is very important. One more thing we need to do is modify my kind cluster. So let me create a folder called clusters. Let's call it kind cluster. I'm going to create another mount on my local machine. So kind cluster. Let me just copy paste some code here. This piece of code is basically saying that I want to create a mount on my local machine to the container host. So this is my container host path, which contains the logs. I'm going to mount it with my host path on my local machine. So if I create a folder here called tmp, so this is a temporary folder. Hopefully I will be able to see my logs created here in this temporary folder. So that's what this piece of code is doing. So go back to install airflow with persistence. I'm going to modify my kind create cluster with --config k8s clusters kind cluster.yaml. Okay, this looks good. We added the persistent volume claims, and we modify our cluster to mount to add an extra mount for a host and path, for a host path and container path. So I'm just going to reinstall Airflow with this new cluster. So let me just close my tabs again. Let's do install Airflow with persistence. Before I install, I also need to, one more thing is I need to update my chart path. So I need to update this to values-override-persistence. Values override persistence.yaml. So this is important. So let me just reinstall Airflow. Let's wait a few more minutes. Okay, so let's go back to our local host, admin. If I click on DAGs, click on example DAG, let's hit trigger. So now we can see our logs are going to persist. So now it's running. Okay, this is amazing. So our task is completed and we can still see our logs because it's currently being persisted in our container in our persistent volume. So this mount Airflow data logs in our container is currently being mounted with this temporary folder here. So you can see DAG ID, run ID, hello world, attempt 1. These are our logs here. Let me just add a .git ignore. Okay. So now we have logging. So this was great. Let's move on to part 3, which is the final part of this video. We're almost at the end of the video. I'm going to keep part 3 super short and simple. And in this part, we're basically going to create a very simple CI/CD pipeline to build our Docker image and push it into a container registry, such as AWS ECR. So for those of you who don't know, ECR is basically a way for AWS to store our containers. So every time we run Docker build, we can push it to this ECR container registry. And we'll pull our Docker images from this registry. And we'll use that to deploy our Airflow deployment. So let's go back to our code base here. I'm going to set up something called GitHub Actions. And GitHub Actions is a heavily integrated tool that allows you to create CI/CD jobs. So I'm going to create a folder called .github/workflows. And in workflows, I'll create CI/CD.yaml. Over here, every time I push something to my branch, I want my branch to automatically redeploy this into ECR. So let's do that. Let's do name equals push Airflow image to ECR. Oops. On push branches feature demo. Jobs. Let's do build and deploy. Runs on Ubuntu latest. Steps. So when we're writing CI/CD, I'm going to make this CI/CD super simple. It's just going to check out. So let's do users actions checkout. So this code is basically going to do a git checkout on my code base. And let's do configure AWS creds users AWS actions configure -AWS credentials v2 with AWS access key ID, AWS secret key ID, and AWS region. Now I need to fetch my secrets. I'm going to do this. Okay, GitHub Copilot already helped me. But anyways, you basically need to wrap this in the Jinja template and call secrets.AWS access key ID and secrets AWS secret access key ID. If I go back to our GitHub here, click on secrets, click on actions, and make sure you register the secrets here. So new repository secret, type in AWS access key, and type in your access key. So in my case, it would be something like this. Click add secret. Do the same thing for your AWS secret access key. And once you have these, let's go ahead and create an ECR registry. So if I go to AWS console, okay, here's my AWS console. Let me go back to my ECR registry and go ahead and click create a repo and call your repo name whatever you want. It could be my DAX repo. Click create. I've already created mine here. And I'm just going to copy paste this. Let's add an ECR registry. So ECR registry, let's just add these values here. Update secret. Once you have this, go back. Let's do -name login to ECR and uses AWS actions Amazon ECR login v1. So this code just runs your ECR login in order to get the right repo. And the last part of the code is name, build and push Docker image. Over here, I'm going to set my image tag equals, let me just copy paste some code. Go back to the script we created. Just copy paste this code. Put it here. Whoops. Image name, my DAX. And I'm going to copy paste some code again. So I'm basically going to Docker build the ECR registry link, image name, image tag for this Docker file, and just push it. So that's it. It's pretty simple. I'm checking out my code. I'm configuring my AWS credentials. I log into ECR. I build and push an image. And every time I push something to this branch, my CI/CD pipeline will automatically upload my Docker image. So let's go ahead and do that. So I click push, go to actions, we can see, oh, this is a new workflow that's being triggered. And build and deploy is currently being run. And we can see here, it was able to check out my code, configure AWS credentials, log into ECR, and it's currently building and pushing my Docker image. Let me refresh this. Okay, amazing. It looks like it ran successfully. If I go back to ECR registry, click on my repo, you can see, oh, this is the latest tag that was built. So let's go back here. I'm going to copy paste install Airflow with persistence. Let's create a new Airflow script. Let's call it install Airflow with ECR. And over here, instead of building my image, I'm just going to pull it directly from ECR. So first, let's authenticate with ECR. So let's do AWS ECR get login password region. Okay, let me rename these environment variables. I don't need image name anymore. I don't need image tag. I need a region, which is US East 1, ECR repository, and this is going to be my repo. Oh, let's call it ECR registry. The last one is ECR repo. Let's call it my DAX. So once I have these variables, let's go ahead and do login region, Docker login, username AWS, password ECR registry. And now I need to fetch my image tag. Okay, I'm just going to copy paste some code here, which will get the latest image tag from ECR. Okay, this is working. Anyways, I just copy pasted some code. I basically use Copilot to just generate this code. And it's going to fetch all the images in the list, sort them, and give me the latest one. Now I need to load the image into Kind. So docker pull ECR registry, ECR repo, image tag, kind load docker image ECR registry, ECR repo, image tag. So I'm logging into ECR, I'm exporting the latest tag, which right now the only tag is this one. And I'm pulling the image from ECR, I'm loading it into Kind. So if I run install Airflow with ECR, this should work. Oh, one more thing I need to do, my bad, is I need to modify my repo. So right now, values override persistence is still using this mydax repo, but I need to modify this. If I go here, I need to add --set string images -airflow dot repository equals, let's do ECR registry / ECR repo. So this is important. Okay. Whoops. Okay, remember to have this line here and reinstall Airflow. Okay, I'm gonna pause the video here. Okay, looks like install Airflow with ECR is working. If I go back to Airflow, everything seems to be working. Okay, this is amazing. So now this version of Airflow is currently being pulled by our ECR registry here. So this is amazing. So we're basically done with this part here. We have a CI/CD pipeline that's able to push a custom Docker image into ECR. And we're able to pull that custom image into our Kind cluster. Hey everyone, so that's everything I wanted to cover in this video. If you made it this far, a big thank you and congrats. You now know how to build an end-to-end data platform. I hope you learned a ton in this video. When I was first writing out this tutorial, I was a bit scared that a lot of beginners wouldn't be able to follow along. At the same time, I wanted to make it challenging so that you could learn as much as possible. We covered a lot of things. We learned about Databricks, what a data lakehouse is, how to write Spark jobs in a declarative way. We looked at some newer features in Airflow 3.0, how to spin up a local Kubernetes cluster. All these skills will be extremely useful for you in the workplace, and I really hope that, and I genuinely hope that you learn a lot from this video. Having said that, I'll see you next time.